Okay, everybody, welcome to the Mac 1105 Unit 2 test review workshop for the Learning Commons. And I'm Noah Schmidt. I'm a math specialist in the Learning Commons. And so I'll be facilitating the workshop. One thing I would recommend is to pause the recording at the beginning of each question so you can have an opportunity to go over or try the question on your own before you resume playing the recording and watch me go over each individual problem. And so we're going to go over about 19 problems overall that hopefully will be similar to the kind of questions you'll see on your Unit 2 test. Problem 1 says find all the zeros of the function r of x equals x squared plus 5x minus 14. To find the zeros of a function, you want to set r of x, for this particular function, you want to set r of x equal to 0 and then solve for x. So you have 0 equals x squared plus 5x minus 14. And then to solve that for x, you'd start out by factoring the polynomial. So you make two parentheses. The first term in each parentheses should be x, because x times x is x squared. And then the last terms in each parenthesis should be whatever numbers would multiply to give you negative 14 and add to give you positive 5. The numbers that would do that would be negative 2 and positive 7. So you'd have x minus 2 times x plus 7. And then to solve the equation for x, we want to set each of those factors equal to 0 and solve them for x. So we'd have x minus 2 equals 0, and we'd have x plus 7 equals 0. To solve x minus 2 equals 0, we would want to add 2 to each side to cancel the negative 2 out, and you'd have x equals 2. To solve x plus 7 equals 0, we would want to subtract 7 from each side, and we would be left with x equals negative 7. So our two solutions that are the zeros of the function are x equals 2, comma, or negative 7. So those would be your zeros for this particular function. Number 2 states, given the function, this is a piecewise function. The function is 6x plus 5 only when x is less than negative 3. It is 2x squared minus 3x minus 40, but only when x is greater than or equal to negative 3 or less than 2. And it is x minus 40, but only when x is greater than or equal to 2. We're going to calculate the following values. We're going to calculate p of negative 7. Negative 7 represents your x coordinate. You're going to plug that number or substitute that number in for x, but you have to determine which function to substitute the number in for, because the function varies depending on what x is. Now, negative 7 falls in the range of being less than negative 3, so that would be, we would want to use the top function to substitute in for x. So we would have 6 times, instead of x, we put negative 7 plus 5, and then simplify the expression. So 6 times negative 7 represents negative 42, and then negative 42 plus 5 gives us negative 37. P of 1 represents x, and that number falls between negative 3 and 2, greater than or equal to negative 3 or less than 2, and less than 2. So we're going to use the middle function for that to plug the 1 in. So we would have 2 times 1 squared minus 3 times 1 minus 40. So this ends up being 2. To simplify this expression, the first thing to do in order of operations is exponents. We would take 1 squared. That would give us 1. Then we would do perform any multiplication from left to right, or division from left to right. In this case, we have multiplication. So 2 times 1 gives us 2. 3 times 1 gives us 3. And we're left with 2 minus 3 minus 40. And when we work that from left to right, because that's all subtraction, we get negative 41 to be our result there. P of 5 falls in the range of being greater than or equal to 2. So we want to substitute 5 in for x for the bottom equation. So 5 minus 40 is negative 35, which would be our result there. The next problem states, a patient has an illness that typically lasts about 24 hours. The temperature T in degrees Fahrenheit of the patient T hours after the illness begins is given by T of T equals negative 0.0576 T squared plus 0.8 T plus 96.9. Use your calculator to graph the function and answer the following questions. We're going to round all answers to 1 decimal place. A says, when does the patient's temperature reach its maximum value? Well, the vertex of a quadratic function represents the maximum of the function or the minimum of the function. In this case, it's a maximum. Now, the x-coordinate of the vertex represents in this case, the answer to problem 1 is the first question is the x-coordinate of the vertex, but it's not x in this problem, it's little t. But we use the same formula, which is negative b over 2a. So to solve for when a patient's temperature reaches its maximum, we're going to set little t equal to negative b over 2a. Now, a is negative 0.0576, b is 0.8, and c is 96.9. This ends up being little t equals negative b, which is negative 0.8, over 2 times, instead of a, we put negative 0.0576. And we just simplify that. So this is negative 0.8 over 2 times negative 0.0576 is negative 0.1152. And negative 0.8 over negative 0.1152 is 6.9 hours rounded to 1 decimal place. B says, what is the patient's maximum temperature during the illness? Well, the y-coordinate of the maximum represents the maximum temperature because T of T represents what y would normally be. And so if we take our 6.9, which is the little t coordinate of the vertex, and substitute it in for little t, then we get the y-coordinate of the vertex, or in this case, the maximum temperature during the illness. So we're going to find t is 6.9 and substitute 6.9 in for little t everywhere little t is listed in the function. So we have negative 0.0576 times 6.9 squared plus 0.8 times 6.9 plus 96.9. And I would just recommend putting all that into your calculator and letting your calculator perform that calculation. And when you do that, you get 99.7 degrees Fahrenheit as the maximum temperature, rounded to 1 decimal place. The next problem says, make sure you use a negative sign when appropriate. The negative signs on the graph may be hard to read. Count from the origin. We have this function that's on this graph. We have the graph of a function. And the first question says the function has a relative maximum of, now when it asks for the relative maximum, it's asking for the y-coordinate of the maximum. So as the function increases and then starts to decreasing again, that's where our relative maximum is. So it's right here on this graph. The y-coordinate there is 0. So this function has a relative maximum of 0 at x equals, now the x-coordinate of this maximum is 0 as well. So a relative maximum of 0 at x equals 0. And then the minimum, the function has a relative minimum of, so here's where our minimum is. It's the function's decreasing and then starts to increase again. So right here, the y-coordinate of this minimum is -4. And this is at x equals +2. That's the x-coordinate where the minimum occurs. The function is decreasing on the interval. When it asks for where the function is decreasing, it's asking for the range of, in interval notation, the range of x values where the function is going down when you look from left to right. So you can see that the function is going down from here to here, and those x values are 0 to 2. So from 0 to 2, the function is decreasing. So to list that in interval notation, you would put a parentheses, then 0, then a comma, then 2, then a parentheses. Number 5 says, sketch a graph of f of x equals x minus 1 if x is less than or equal to -5, -6 if x is greater than -5, less than or equal to 1, and 2x minus 8 if x is greater than 1. And note, be sure to include closed or open dots at any endpoints. So it's important to note that each of these functions on this particular piecewise function represent lines. Now, what you do is you just graph each function as a line, but only graph it in the range of x values that's given. So x minus 1 is a line. We're going to graph x minus 1, but only graph that line when when the x values are less than or equal to -5. And so what we can do there to graph that is get points, get 2 ordered pairs on that line. Now, -5 can represent one of your x values because it's an endpoint of the interval for that particular x. Substitute it in for x, so you'd have -5 minus 1, you get -6. So -5, -6 is a point on your graph. So if you go to -5, -6, you have a point, and then the next number just needs to be any number less than -5. So I used -6 and substituted that in. -6 minus 1 is -7. So -6, -7 is a point. And I plotted that point. So there's our 2 points, and there's that line for that particular piece. You can see that it stops at -5 for that particular x. -6 is the function when x is greater than -5 and less than or equal to 1. Now, -6 doesn't have an x in it. That's just a horizontal line because it's like being in the form of y equals -6. So just go where y is -6 and plot a horizontal line from x equals -5 to x equals 1. And that's right here. So -5, there's 1, and the y-coordinate is always -6. It's a horizontal line from -5 to +1. And then the next line is 2x minus 8 if x is greater than 1. We need to get 2 ordered pairs on that line as well. So I used 1 as one of my x's to plug in. So if you plug in 1 for x there, you'd have 2 times 1 minus 8. 2 times 1 is 2. 2 minus 8 is negative 6. So 1, negative 6 is a point. There's 1, negative 6 right there. And then if pick another number bigger than 1, I used 2. 2 times 2 is minus 8 is how it's set up. 2 times 2 is 4. 4 minus 8 is negative 4. So 2, negative 4 is a point. And there's 2, negative 4. And then you just draw that line. Now, the middle line already has a closed dot on when x is 1. And so there are no open dots on this particular graph, but you have to be aware of the fact that it's possible you could have an open dot at an endpoint of a line, but we don't have that on this particular line. It's just something to be aware of on this particular piecewise function. The next problem states, use the quadratic formula to solve the equation x squared minus 13x plus 50 equals 0. Fully simplify your answer, including any non-real solutions. So we have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That represents the quadratic formula, which is what we're using to solve this. A in this problem is 1, b is negative 13, c is 50. The way this was set up is that it's negative 13, which is positive 13, plus or minus the square root of b is negative 13 squared, minus 4 times a is 1 times c is 50, all over 2 times a is 1. And then this ends up being 13 plus or minus the square root of negative 13 squared is 169, minus 4 times 1 times 50 is 200, all over 2 times 1 is 2. This ends up being 13 plus or minus square root of 169 minus 200 is negative 31, all over 2. And then we just need to write square root of negative 31 in terms of I. Square root of negative 31 is written as square root of 31i as an imaginary number. So this ends up being 13 plus or minus the square root of 31i over 2. And we want to write that as two separate answers, one with a plus and one with a minus. So it ends up being x equals 13 plus square root of 31i over 2 and 13 minus square root of 31i over 2. The next problem states, solve the quadratic equation by completing the square. We have x squared plus 6x plus 25 equals 0. The first step in completing the square is to move the constant term, if it's not already there, move the constant term to the opposite side as the quadratic term and the linear term. So in this case, 25 represents the constant term, and we would want to subtract 25 from each side to cancel it out and move it over. So you'd end up with x squared plus 6x equals negative 25. Now, the next step in the process, you can see that I already have all the work here, but you would just have x squared plus 6x equals negative 25 at this point. To get the 9 that's showing up here, the way that was determined is I took 6, which is my b, and took half of it. So 6 divided by 2 is 3, and then I squared the 3. So 3 squared is 9. So 9 gets added to each side of the equation. So you end up with x squared plus 6x plus 9 equals negative 25 plus 9. And so this x squared plus 6x plus 9, it needs to be factored. Now it's a perfect square. That's why this is called completing the square. So to factor the perfect square, just take the square root of x squared, which is x, and take the square root of the third term, which is 9, of 9, which is square root of 9 is 3. And then the sign in the middle term tells us the sign of what's inside the parentheses, which is a plus. And it's a square. That's why it's called completing the square. So x plus 3 squared equals negative 25 plus 9 is negative 16. And then to solve this, this allows us to cancel our square out by square rooting each side. And so you're left with x plus 3 equals square root of negative 16 in terms of I would be 4i. So you'd have plus or minus 4i. Now, then we have to get x by itself, so we have to cancel out the 3. We would subtract 3 from each side, and we would be left with x equals plus or minus 4i minus 3, and we need to write those as two separate answers, one with a plus and one with a minus. So this is x equals 4i minus 3, comma, negative 4i minus 3. The next problem says, consider the quadratic formula or function, consider the quadratic function f of x equals negative 2x squared plus 6x plus 14. Find the vertex using the vertex formula and the formula for f of x. The vertex is basically the formula for finding the x coordinate of the vertex is that it's negative b, x equals negative b over 2a. In this function, a is negative 2, b is 6, and c is 14. This is x equals negative b over 2a, so this ends up being x equals negative b is negative 6, because b is 6, over 2 times, instead of a, we put negative 2. Negative 6 over 2 times negative 2 is negative 4, but the two negatives, the negative 6 over negative 4 gives us positive 6 over positive 4, because the two negatives become positive, and we have to reduce the fraction. So we would divide by the greatest common factor, which is 2. This ends up being 6 divided by 2 is 3, and 4 divided by 2 is 2. So this is x equals 3 halves. Now, in all likelihood, on your test, the system is probably going to want your answer as a reduced fraction. So we're going to leave our x coordinate to be 3 halves. Now, 3 halves, to get the y coordinate, is 3 halves is plugged in for x, and then we'll simplify the function to get the y. So this is f of 3 halves equals negative 2 times 3, instead of x, we have 3 halves squared, plus 6 times, instead of x, we have 3 halves, plus 14. Always we want to do exponents before we multiply, so 3 halves squared is 9/4. So you have negative 2 times 9/4, and then I basically took 6, well, I skipped a step here, but I took 6 times 3 halves and got 18 over 2. 6 times 3 is 18 over 2, plus 14. Now we need to get, when this ends up, we end up with negative 2 times 9, which is negative 18 over 4. 4 is going to be the common denominator because we got a denominator of 4, 2, and 1. So I basically converted all the denominators so that the denominator is 4 for all the denominators. So to get 2 from 2 to 4, 2 would need to multiply by 2. So I also multiplied the 18 by 2. And then to get from 1 to 4, I'd need to multiply by 1. So I also needed to go from 1 to 4, I needed to multiply by 4. So I needed to multiply the 14 by 4 as well. And when you do all that, you end up with negative 18 over 4 plus 36 over 4 plus 56 over 4. And since all the denominators are 4, it's just a matter of adding adding left to right. So negative 18 plus 36 plus 56 gives us 74 over 4. The last step is to reduce the fraction. So we divide by 2 on the numerator and denominator because 2 is the greatest common factor. 74 divided by 2 is 37. 4 divided by 2 is 2. So 37 over 2 represents the y-coordinate of the vertex. So the vertex is 3/2, comma, 37 over 2. The next question says, consider the function g of x equals negative x squared plus 4x minus 3. Graph g of x. Include on your graph and label. So the vertex is the first thing we want to find. And to find the vertex, we would want to use negative b over 2a to find the x-coordinate of the vertex. A is -1, b is 4, and c is -3. So this ends up being x equals -4 is basically negative b, and then 2 times -1 is a. So this ends up being -4 over -2, which ends up being +2 for your x-coordinate of the vertex. Then you substitute 2 in for x to get the y-coordinate of the vertex. This ends up being -2 squared plus 4 times 2 minus 3. And when we work all that out, the -2 squared gives us -4, plus 4 times 2 is 8, minus 3, and then -4 plus 8 minus 3 is 1. So this 2, 1 represents our vertex, and I went ahead and plotted that. That's right here. The x-intercepts are the x-coordinates that you get when you set 0 in for y. And so over here, I set 0, and substitute 0 in for y, and we have 0 equals -x squared plus 4x minus 3. And that's a quadratic equation that we can solve by factoring. So the way to factor that, what I did is, since the negative is the leading coefficient is negative, I substituted factored the negative out from the function, and when I did that, it changed all the signs inside the parentheses. So I ended up with negative and then x squared minus 4x plus 3. And then set your factors equal to 0 and solve them for x. So x minus 3 equals 0. To solve that for x, you would want to add 3 to each side to cancel the -3 out. So you'd have x equals 3. And then for x minus 1 equals 0, you'd add 1 to each side, which gives you, to cancel the -1 out, and then that gives you x equals 1. So your x-intercepts are 3, 0, and 1, 0. 3, 0 is right here, 1, 0 is right here, and I plotted those 2 points. The y-intercept is what you get when you substitute 0 in for x. So if you substitute 0 in for x, then all you'd be left with is -3. So 0, -3 is the y-intercept, and you plot that ordered pair. 0, -3 is right here. And then we need one other point. Now, to get one other point, you just need to pick an x-coordinate to plug in for x. Now, how would you determine which x to plug in? Well, I've got x to be 0, 1, 2, and 3. So I just picked the next number on the right, which is 4 for the x there. And that balances the function out as far as which x's you have. If you substitute 4 in for x, you have -4 squared plus 4 times 4 minus 3. Negative 4 squared is negative 16 plus 4 times 4 is 16 minus 3. Negative 16 plus 16 minus 3 is negative 3. So 4, negative 3 is a point on the graph. So if you plot 4, negative 3, that's right here. And then you can just trace through the points and you have the parabola for this particular function. The next question says, graph s of x equals 6x over x squared plus 4 on your calculator and answer the following questions. It says graph at least 8 points. I didn't do that. It's really not necessary to graph that many points. You just need to find the relative maximum and the relative minimum on the graph, and you can kind of tell how the graph is going to look. Now, the way you're going to do that is first thing you'd want to do is graph this function on your calculator. And to find the relative maximum, you do second trace maximum, set a bound, make sure your cursor's to the left of the maximum, hit enter, move the cursor to the right of the maximum, hit enter, and then hit enter one more time to guess, and that'll give you the relative maximum of the function. And then you do the same thing to find the relative minimum of the function. The relative maximum of the function is 2, 1.5, which I've got plotted here. The relative minimum of the function is negative 2, negative 1.5, which I've got plotted right here. I can't really show you the steps visually because I don't have a dot cam that I can pull up, but I can show you what the answer should be for this particular problem. There's our minimum, there's our maximum. The function is just going to slide along the x-axis as you go off to infinity for your x's, and it slides off near along the x-axis as you go to negative infinity for your x. So the function looks kind of like this. Now, A says this s of x is increasing on the interval from what to what? Well, it's increasing from here to here, and the x coordinates there are negative 2 to positive 2. So you'd put parentheses negative 2, comma, positive 2, parenthesis. B says s of x is decreasing on the interval from, now it's decreasing from negative infinity all the way to where x is right here, which is negative 2. So from negative infinity to negative 2, union, and then it's also decreasing right here. That's from x equals 2 off to infinity, so 2, comma, infinity. S of x has a relative maximum of, so the relative maximum is the y value of the maximum, and the y value of this maximum is 1.5, and it's at x equals 2. And then S of x has a relative minimum of, here's the relative minimum right here. That relative minimum is negative 1.5, and it's when x is negative 2. The range of S of x is all possible y values, and all possible y values of the function. You see the graph never goes below negative 1.5, and it never goes above positive 1.5. So from negative 1.5 to positive 1.5 is your range. So you put parentheses negative 1.5, comma, 1.5 parentheses. An object is thrown, this is number 11, an object is thrown upward at a speed of 135 feet per second by a machine from a height of 15 feet off the ground. The height of the object after t seconds can be found using the equation h of t equals negative 16t squared plus 120 or 135t plus 15. Give all numerical answers to 2 decimal places. Please include the correct units. Now, A says, when will the object reach its maximum height? Now, the way I'm having you do this particular problem is you got to find the relative maximum of the function. So I'm going to have you graph this function on your calculator and use second trace and scroll to the left for left bound, scroll to the right of the maximum for right bound, and then hit enter again to guess. And the x coordinate of that maximum represents when the object will reach its maximum height. And that number is, you should get t equals 4.22 seconds. Now the y coordinate of the maximum would represent your maximum height, because that's problem B. What is its maximum height? Now, when you did that on your calculator, your y coordinate that you should have gotten is 299.77 feet, rounded to 2 decimal places. And then C says, when will the object hit the ground? Now, the height of the object when the object hits the ground, the height of the object is 0 feet. So if you substitute 0 in for h of t and solve for little t, then you would have the time that the object reaches the ground, the time it takes for the object to reach the ground. So that's like finding the zero of the function. Now there's a way you can use your calculator to find the zero as well. Just after you hopefully have already graphed this on your graphing calculator, you use second trace, and instead of highlighting maximum, you'd highlight 0. And so you'd highlight 0 and hit enter, and you just find where the graph is crossing the x-axis and set a left bound and a right bound and guess on that. So have your cursor to the left, hit enter, have your cursor to the right, hit enter, and then hit enter one more time to guess, and you'd have the time the object reaches the ground. And what you should get for the time it takes for the object to reach the ground is 8.55 seconds, rounded to 2 decimal places. 12 says, solve the equation. If there is no solution, write D and E. This is absolute value of 5x minus 10 equals 30. The way to solve an absolute value equation is if the equation, absolute value is always positive. So if 5x minus 10 is equal to 30, that's a solution. And if you set 5x minus 10 equal to negative 30, that's also a solution, because if 5x minus 10 were negative 30, the absolute value would make it positive 30. So you just set it equal to positive 30 and negative 30 and solve each equation individually. So for 5x minus 10 equals 30, we would add 10 to each side first to cancel the negative 10 out. That would give us 5x equals 40. Then to cancel the 5 out, we would divide by 5 on each side, and that would give us x equals 8. And then for 5x minus 10 equals negative 30, we would add 10 to each side to cancel the negative 10 out. That would give us 5x equals negative 30 plus 10 is negative 20. And then divide through by 5 on each side, and that would give us x equals negative 20 over 5 is negative 4. So you have x equals 8 or negative 4. That's your two solutions on this particular problem. The next problem states absolute value of negative 7x plus 12 minus 22 equals 15. Now you need to set your absolute value equal to a positive and negative number, but not until we move the negative 22 over, because the absolute value part of the equation has to be by itself. If we add 22 to each side, that would be negative 22 plus 22. That would cancel out, and you'd have 15 plus 22 is 37. Now, you would set negative 7x plus 12 equal to 37, and you'd set negative 7x plus 12 equal to negative 37 as well. And so if we solve each of those for x, for negative 7x plus 12 equals 37, we would want to subtract 12 from each side. To cancel the 12 out, you'd have negative 7x equals 25, and then we would want to divide through by negative 7 to cancel the negative 7 out in front of x, and you'd have x equals negative 25 over 7. And you really should just leave it like that. There's not any simplification you could do there. Then you'd have, for the other equation, you'd have negative 7x plus 12 equals negative 37. And so you'd want to subtract 12 from each side to cancel the 12 out. You'd have negative 7x equals negative 37 minus 12 is negative 49. And then the last step is to then divide by negative 7 on each side, and you'd be left with x equals negative 49 over negative 7 is positive 7. So your two solutions are x equals negative 25 over 7, comma, or positive 7. The next question says solve absolute value of negative 2x minus 7 is less than 8. Keep in mind that for the absolute value of negative 2x minus 7 to be less than 8, that means the total distance from 0 on a number line for negative 2x minus 7, it needs to be less than 8. The only way that's possible is if negative 2x minus 7 is between negative 8 and positive 8. Because if it's between negative 8 and positive 8, then its absolute value is less than 8. So you're solving this for x, and you want to add 7 to cancel the negative 7 out, but you have to add it everywhere on the inequality. So you'd add 7 here and here, and negative 8 plus 7 is negative 1. 8 plus 7 is 15, and then the negative 7 here canceled out. So now you're left with negative 2x is greater than negative 1 and less than 15. Now, you got to cancel the negative 2 out by dividing by negative 2 on everything. But when you divide everything by a negative number on an inequality, you have to flip the inequality symbols. So you divide through by negative 2 on everything, and you cancel the negative 2 out here, and you have negative 1 over negative 2, which is positive 1/2. But then the inequality symbol flips, and then you have 15 over negative 2 is just negative 15/2, and that inequality symbol flips. So what you're left with is that x is greater than negative 15/2 and less than 1/2. So the solution to this equation is that you go from parentheses negative 15/2, comma, 1/2 parentheses. This problem states solve absolute value of 5x plus 8 is greater than or equal to 3. For absolute value of 5x plus 8 to be greater than or equal to 3, that means 5x plus 8, the distance from 0 on a number line needs to be larger than or equal to 3. The only way that's possible is, like I've illustrated on this number line, is if 5x plus 8 is greater than or equal to 3, or 5x plus 8 needs to be less than or equal to negative 3. So on both of those inequalities, the distance from 0 on the number line for 5x plus 8 would be greater than or equal to 3. And we're going to solve each of those inequalities. It's a compound inequality. So 5x plus 8 is greater than or equal to 3. We would subtract 8 from each side to cancel the 8 out. And you'd have 5x is greater than or equal to 3 minus 8 is negative 5. Then we divide through by 5 on each side. And you have x is greater than or equal to negative 1, because negative 5 over 5 is negative 1. or then we have to solve the other inequality, and so we would subtract 8 from each side to cancel the 8 out. You have -3 minus 8 is -11. Divide through by 5 to cancel the 5 out in front of x, and you have x is less than or equal to -11 over 5. And so there's two inequalities there that are part of the solution to this absolute value inequality. X greater than or equal to -1 would be the interval notation for that would be from parentheses -infinity, comma, negative, it's actually, no, negative x greater than or equal to -1 is basically the bracket -1 to infinity parenthesis. I kind of told you that a little out of order. This is the upper interval, and then the lower interval is x is less than or equal to -11/5, and that inequality in interval notation would be from parentheses -infinity, comma, -11/5 bracket. And the reason there's a bracket is because it could equal. There's an equal sign underneath the inequality. So your two intervals for your solution are -infinity, -11/5 with a bracket, union, bracket -1 to infinity parenthesis. Given f of x equals -4x squared plus 3x, find f of x plus h minus f of x, now over h. So this is called the difference quotient. The first thing to do is find f of x plus 8 by substituting x plus h in for x. So you'd have f of x plus h equals -4 times parentheses f of x times parentheses x plus h squared plus 3 times parentheses x plus h. X plus h squared, if you FOIL that, which I've done up here, you end up with x squared plus 2xh plus h squared. So it ends up being -4 times x squared plus 2xh plus h squared. Plus, then you take the 3 times x plus h and distribute 3. That ends up being 3x plus 3h. So all that put together ends up being -4. The -4 has to distribute inside the parentheses. You have -4x squared, and then -4 times 2xh is -8xh, and then -4 times h squared is -4h squared. And then you have plus 3x plus 3h, then minus, there's the minus part, and then f of x is just the function as it is. F of x as it is, which is, it was -4x squared plus 3x, but the negative distributes, the minus distributes to both terms, and I just went ahead and switched the signs there. I switched my negative to a positive and switched both of the signs for f of x. So -4x squared becomes 4x squared, and 3x becomes -3x. And so this is all over h. And so then we're going to try to combine like terms. Now we see that -4x squared and +4x squared can cancel out, and -3x and +3x cancels each other out. So all we would be left with is -8xh minus 4h squared plus 3h, all over h. Now, since there's an h that's a common in every term, we can factor out the h on the numerator And when we do that, the h factors out and you're left with negative 8x minus 4h plus 3 left in the parentheses. And this is all over h. Now the h that we factored out and the h in the denominator can be canceled. They cancel each other out. And all we're left with here is negative 8x minus 4h plus 3 would be your final result for this. Now we get into simplifying complex expressions. 16 says simplify the following expressions. Square root of negative 28. Now, this needs to be simplified. Now, the way to simplify it is even though it's negative, we would want to simplify it as if it's the same way as if we would be simplifying a radical that's positive. So make two new square roots. The first square root needs to contain the largest perfect square that'll factor into negative 28. That would be 4. And then 4 times negative 7 gives you negative 28. So negative 7 goes in the other radical. So square root of 4 is 2. And then square root of negative 7 has to be written as a complex number or as an imaginary number. So square root of negative 7 written in terms of I is square root of 7i. So we have 2 square root of 7i there. The next problem says negative 2 plus 48 over 4. Now, square root of 48 needs to be simplified, so we make 2 new square roots. The largest perfect square that'll factor into 48 is 16. And 16 times 3 gives us 48. So square root of 16 is 4. So this is 4 square root of 3 that replaces square root of 48. So you have negative 2 plus 4 square root of 3 over 4. And then the negative 2 and the 4 can be reduced, can be all divided by 2. So you'd end up dividing each of those by 2. You'd have negative 2 divided by 2 is 1. And then 4 divided by 2 is 2. All over 4 divided by 2 is 2. So all we're left with is negative 1 plus 2 square root of 3 all over 2. And so then 17, we're going to solve the equation 5w squared equals 12w plus 9. And I'm going to do this solve this equation by factoring. So the first thing to do is to get everything all on one side so it's set equal to 0. And you want to do that so that the leading term stays positive. 5w squared is already positive, so we're going to subtract 12w and subtract 9 from each side to move it over and cancel it out on the right side. So you have 5w squared minus 12w minus 9 equals 0. To factor 5w squared minus 12w minus 9, we make 2 new parentheses. And then the first terms have to be 5w and w because that's the only way you're going to multiply to get 5w squared. And then the end terms have to multiply to give you negative 9, but they don't necessarily add to give you negative 12 because the leading coefficient is not 1. The outer-inner combination that then gets added has to be negative 12w. So if I put 3 next to 5w and negative 3 next to w, if I multiply my outer terms, 5w times negative 3, I get negative 15w. And if I multiply my inner terms, 3 times w, I get 3w. And negative 15w plus 3w is negative 12w. So that's why it's the correct factorization. But in order to solve this equation, we have to set each of our factors equal to 0. So 5w plus 3 is set equal to 0. and w minus 3 gets set equal to 0. 5w plus 3 equals 0. The first step there is to subtract 3 from each side to cancel the 3 out. You'd be left with 5w equals negative 3, and then we have to cancel the 5 out that's in front of w, so we divide by 5, and we get w equals negative 3/5 as one of our solutions. To solve w minus 3 equals 0, we would want to add 3 to each side to cancel the negative 3 out, and you'd be left with w equals positive 3. So negative 3/5, comma, or positive 3 are your two solutions on this. The next problem says, solve the equation using the completing the square method. Now this is already set up for you because the constant term is already on the opposite side of the quadratic term and the linear term. We just need to take half of negative 6. Negative 6 divided by 2 is negative 3, and then square it. Negative 3 squared is 9, so 9 has to get added to each side. You have x squared minus 6x plus 9 equals negative 1 plus 9 is 8. And then if you remember from the previous problem that we completed the square on, it's a x squared minus 6x plus 9 is a perfect square, and the way to factor it is to take the square root of the first term. The square root of x squared is x. The square root of 9 is 3, and then the sign of the middle term is negative, so this is x minus 3 squared equals 8. And then the way to cancel the square out is to square root each side. And you have x minus 3 squared equals, or actually when you square root, you end up with x minus 3 equals plus or minus the square root of 8. Whenever you square root a square, you have to have a plus or minus. And then we've got to get x by itself, so we're going to add 3 to each side, and we have x equals plus or minus square root of 8 plus 3. We need to try to break down the square root of 8 and simplify it, and so I did that off to the side over here. The largest perfect square that'll factor into 8 is 4, and 4 times 2 is 8. The square root of 4 is 2, so this is 2 square root of 2. And so you have plus or minus 2 square root of 2 plus 3. So you have to separate your two answers. X equals 2 square root of 2 plus 3, and then comma negative 2 square root of 2 plus 3 would be your two solutions. The last question is, consider the function f of x equals 2/3 times x plus 3 squared minus 4, round to 2 decimals when necessary. Use your calculator to help you find the answers to this one. We want to graph f of x, and then make sure you draw the axis of symmetry as a dashed line. I didn't do that, but let me do that really quick. There's the axis of symmetry. So let's go over how I got this particular graph. Okay, so before I graph it, I got to go through all the different steps to graphing it. And the first step when you have a quadratic equation is always to find the vertex. Now the vertex, this is in vertex form. So the x coordinate of the vertex is the number that's inside the parentheses with x as its opposite. This is like x minus h. Now h would have to be -3 because x minus -3 is +3. So -3 is the x coordinate of the vertex. The y coordinate of the vertex is the number that's on the end outside the parentheses, which is -4. So -3, -4 represents your vertex. The axis of symmetry is a vertical line through the x coordinate of the vertex. And so that vertical lines are always in the form of x equals some number. So this is x equals -3, because -3 is the x coordinate of the vertex. Does the f have a maximum or minimum, and what is its value? Well, the maximum or minimum is the y-coordinate of the vertex, and the y-coordinate of the vertex is -4, so this is -4. Now, the way to determine if the function has a maximum or minimum is you go by the sign of the leading coefficient. Now, this function, the leading coefficient of this will be positive, and if it's positive, that means this graph is facing upward. And if it's facing upward, then it has a minimum and not a maximum. So this has a minimum of -4. If the leading coefficient is negative, then it's facing down and it has a maximum. The x-intercepts are what you get when you put 0 in for y and solve for x. So I did that up here. I put a 0 in for y. And what I did first is I've got 2/3 in front of x plus 3 squared, so I multiply by 3/2 to cancel 2/3 out. And so, and really you, if you did that, you basically, all right, so there's actually a little bit of a mistake here. There needs to be, the first thing you would want to do is you'd want to add 4 to each side. So it should actually be a 4 that's over here rather than 0. But then you would want to multiply by 3/2. And so what you'd have, you wouldn't have 0 over here anymore. You'd have 3/2 times 4, you'd have 6. So you'd have 6 equals x plus 3 squared. And so then you'd have square root, you'd have to square root the square up here, and you'd have square root of 6. You'd have plus or minus square root of 6. Equals x plus 3. So this should actually be plus or minus the square root of 6. And then you subtract 3 from each side. So you get really just square root of 6 minus 3 and negative square root of 6 minus 3 as your two x-intercepts. Now that's kind of a messy problem on this, but the idea is that it's pretty close to where I put it originally, but you basically are about right here for your x-intercept, for one of your x-intercepts. So square root of 6 is actually 2.24, and if you take 2.24 minus 3, that's negative 0.76. That's about right here for one of your x-intercepts. And then negative 2.24 minus 3 is negative 5.24. So that ends up being right here. And so it's pretty close to being -5 and -1, but it's more of a decimal, and you kind of have to estimate where it would be. So let's just call our x-intercepts to be negative 0.76 and negative 5.24. Now the y-intercept, though, is what you get when you plug 0 in for x. So if you plug 0 in for x here, so I did that over in this area right here, you find f of 0, that equals 2/3 times 0 plus 3 squared minus 4. inside the parentheses, 0 plus 3 is 3, and 3 squared is 9, and that multiplies by 2/3, and then you subtract by 4. Now 2/3 times 9 over 1 is 18 over 3 minus 4, and 18 divided by 3 is 6, and then finally you have 6 minus 4, and you have 2. So 0, 2 is your y-intercept, and that's right here. So that gives you enough to be able to draw the parabola. And so the equation of the line of symmetry as a dashed line is basically this vertical line through -3 for your x. So with that, that's pretty much all the questions that we have on this particular review. Remember that you're able to get tutoring from the Learning Commons using the procedures for online tutoring that we sent at the Learning Commons, sent you at the beginning of the summer term. And also, please feel free to email me back if you have any questions about this particular PowerPoint. And I hope you guys do well on your test. Thank you, everybody.